This is lesson 2-3, multiplying and dividing rational numbers. We have two vocabulary words in this section. The first one, multiplicative inverse. The multiplicative inverse is a fancy name for saying reciprocal. Essentially what it means is it's the flipped over version of the same number. If you have A over B, the multiplicative reciprocal is B over A. For example, if I have 3 over 2, the multiplicative inverse is 2 over 3. You can tell something is a multiplicative inverse because if you multiply them together, they should equal 1, because this would be 6 over 6, which equals 1. A number and its multiplicative inverse multiplied together equals 1. A reciprocal is another name for multiplicative inverse. Those are synonymous. You will hear them used and interchanged quite frequently. Now we're going to go over some properties of multiplication. There are 3 basic properties of multiplication. All 3 of them are fairly simple and straightforward. The identity property of multiplication says for every real number n, if I multiply that by 1, I get back to my real number. Essentially what that is saying is it's an identity property because it does not change the original number. 1 times -5 stays at -5. Anything multiplied by 1 stays at the original problem. The multiplication property of 0 says that whenever you multiply something by 0, your answer should be 0. If I have any real number n, n times 0 is 0, and 0 times n is also 0. Multiplied by 0 stays as 0 as your final answer. The multiplication property of -1 is a nice way of saying the opposite. If you want to change something to the opposite, you multiply it by -1. For every real number n, -1 times n equals -n, and n times -1 equals -n. It changes it to its opposite. -1 times 5 equals -5. -5 is the opposite of 5. You get that by multiplying it by -1. Multiplying and dividing rational numbers. We had specific rules for adding and subtracting integers. Now we're going to have rules for multiplying and dividing integers. For example, we'll start with this one. Multiplying and dividing numbers with the same sign. It's very simple. Multiplication and division is very, very simple. If the signs are the same, you keep then it's positive. If the signs are different, it's negative. The product or quotient of 2 positive numbers or 2 negative numbers is always positive. Another way I like to say it is count up how many negative signs you have. Odd number of negative signs, your answer is negative. Even number of negative signs, answer is positive. Okay? And that's the same thing for multiplication and or division. If you have different number of signs, then it's going to be negative. It's the most simplest way. For example, let's just say I have the following problem. -1 times 1 times 5 times -3 times 2 times -1 times 4 times -3. Is my answer going to be positive or negative? The easiest way to do this, let's look up the number of negative signs we have. I have 1 negative sign, 2, 3, 4 negative signs. 4 is positive. My answer will be positive. I will have a positive answer for this. If it had an odd number of negative signs, my answer is negative. That's the easiest way to remember it. So let's look at some problems. Multiplying and dividing rational numbers. If we're going to simplify these expressions, I have -3 times -11. 2 negative signs, that's even, so my answer is going to be positive. So if 3 times 11 is 33, my answer stays as positive 33. Here I have 1 negative number and 1 positive number, so my answer is going to be negative. I can go through all of these problems right now and answer whether or not my answer is going to be positive or negative right away, without having to do the multiplication first. If I look at this one, 2 negative signs, answer is going to be positive. 1 negative sign, answer is going to be negative. Down here, 2 negative signs, answer is going to be positive. Now I can actually do the math. If I multiply 6 over 1 times 3 over 4, I'm going to get -18 over 4, which I can reduce. 2 goes into 18 -9 times, and it goes into 4 twice. And you can leave it as an improper fraction. You do not need to change it to a mixed number. It's much easier to leave it in this form. Negative 4.9 times 8. Remember, with decimals, you do not need to line up the decimal point. So 4.9 times 8. 8 times 9 is 72. Carry my 7. 8 times 4 is 32, plus 7 is 39. I have one digit after the decimal point, so my decimal should be there. We know the answer is positive, so my answer is 39.2. For number 4 here, I have one negative sign, so it's going to be negative answer. 70 is divided by 5, so 70 divided by 5. 5 goes into 7 one time. 5 goes into 24 times. And my answer, I already said, was negative, so we know it should be negative 14. Bottom problem down here, negative 54 divided by negative 9. Two negative numbers, and my answer is going to be positive. 9 times 6 is 54, so 54 divided by 9 should be 6, and my answer is positive 6. And you can also evaluate when you're multiplying and dividing rational numbers. Again, you're going to do just like you did with addition and subtraction. You're going to substitute all the numbers in first, and then follow the proper order of operations. So this says the opposite of C times D. So I'm going to have the opposite of C is negative 8, and D is negative 7. Notice how I don't use an X, so I don't get confused with my variable. I have three negative signs, so my answer is going to be negative. 8 times 7 is 56, so it's negative 56. Here I have the opposite of C, so I have the opposite of negative 8 times negative 7. Again, I still have three negative signs, so my answer is going to be negative. And 8 times 7 is 56, and it should be a negative answer. Number 3 here, I have C, which is negative 8, times the opposite of D, which is, this says opposite of D, so that's going to be times 7. Again, negative 56. Seems to be a pattern here with lots of 56s coming up. And then we have number 4 here, where we are going to do negative 2 times negative 3 times C times D. So negative 2 times negative 3. C is negative 8, and D is negative 7. So we have all of these, and it doesn't matter what order you tend to do them in. You can put them in whatever order you want. I'm going to do these two. This makes it positive 6. These two is positive 56, so I now have 6 times 56. I'm going to get a positive answer. 6 times 56. Let's see, 56 times 6, there's 6 is 36, 6 times 5 is 336. And it should be positive. I had an even number of negative signs, 1, 2, 3, 4, so my answer should be positive. Last problems. We have to be careful when we simplify and add to that the exponents. You want to be very, very careful and make sure that you, every time you're working with exponents, if you're going to substitute in, you need to make sure you substitute in with parentheses because of this. And this is a very important part. This problem actually says the opposite of 4 to the third. That's what it's saying. It's saying the opposite of 4 to the third, which means it means this, 4 to the third, like that. The negative sign stays on the outside. So we'll take 4 times 4 times 4. So it basically looks like this. 4 times 4 is 64. 64 times 4 is 216. So this answer should be negative 216. No, wait, that's wrong. 4 times 4, oh, let's start that again. That was bad. 4 times 4 is not 64. 4 times 4 is 16. Oops, now I'm erasing the whole entire problem. Let's start again. Okay, so this would be the opposite of 4 times 4 times 4. 4 times 4 is 16, times 4 is 64, and we have the opposite of that, so the answer is negative 64. Now this problem, number 2, is different than number 1. Number 1 said the opposite of 4 to the third because the negative sign was outside of the parentheses. Here, the negative sign is inside the parentheses. So this means negative 2 times negative 2 times negative 2. That's exactly what the problem is saying. Negative 2 used as a factor 3 times. So my answer is going to be negative. 2 times 2 is 4, times 2 is 8. So the answer is negative 8. Not a big deal if you don't think about it, but it can be a very big deal because of the fact that this exponent 3, if it's an odd numbered exponent, it does change your sign being positive or negative. If it's an even numbered exponent, it can also change your sign, because number 3 says negative 2 to the 4th is negative 2 times negative 2 times negative 2 times negative 2. 2 times 2 is 4, 2 times 2 is 4, 4 times 4 is 16, and it should be positive 2 of an even number of negative signs. And I'm going to move number 4 down a little bit so we can see it a little bit. It says the opposite of 2 to the 3rd. Okay? It says the opposite of 2 to the 3rd. So if we look at problem number 4, I'm going to highlight this for a moment. Here's problem number 4. It's different from problem number 2. They look similar, but they're very different. Here's the answer to problem number 2. Now let's look at problem number 4 for a minute. I'll even do it in a different color. Problem number 4, I'm moving down to here. It's the opposite of 2 to the 3rd, which means negative parentheses 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, so this is negative 8 should be my answer. Notice the difference between these two problems. Okay? You get the same answer, but the difference is in how they are set up. Notice how 4 here has the opposite of 2 to the 3rd, and 2 is negative 2 times negative 2 times negative 2. It massively changes when you look at problems 3 and 5. Let's look at problem 3 again. Here's problem 3, and here's the answer to problem 3. Now let's look at problem 5 for a moment. If we look at problem 5, this is the opposite of 2 to the 4th. Okay, 2 times 2 is 4, 2 times 2 is 4, 4 times 4 is 16, but we're taking the opposite of that. Notice how problem number 5 is a negative 16, while problem number 3 over here is a positive 16, because of where the negative sign is. So it's very important that you understand where to put that negative sign. Last but not least, let's talk about division. We've done a lot of multiplication and not a lot of division. The inverse property of multiplication shows that for every non-real number a, there's a multiplicative inverse 1 over a, such that when you multiply them together, they equal 1. We talked about that. A number's inverse, when it multiplies by itself, becomes a positive 1, which means if the number is positive, it's multiplied by its inverse, it's going to be positive. The inverse of negative 8, the multiplicative inverse is negative 1/8, so that my answer is still a positive 1. So let's look at this problem down here. We're going to evaluate negative x over y minus 4z squared for x equaling 4, y equaling negative 2, and z equaling negative 4. So the first thing I'm going to do is I'm going to substitute in all my values. I have a negative, x is 4, so I'm going to put a 4 over here for x. Y is negative 2, so I'm going to put a negative 2 down here. Notice I didn't lose any of my negative signs. Minus 4 times z, which is negative 4, squared. Now I need to follow the proper order of operations. When a fraction is negative, as long as it has one negative sign, it's negative. For example, let's say I have the fraction 3/5. Negative 3/5 can be written 3 different ways. It can be written with a negative sign in the middle of the fraction, it can be written with a negative sign in the numerator, or it can be written with a negative sign in the denominator. As long as there is only one negative sign within a fraction, the fraction is negative. Here, on this problem, I have 2 negative signs, which essentially means that these 2 negative signs will cancel each other out, and I will have a positive answer here, because a negative divided by a negative is a positive. 4 divided by 2 is 2, minus 4 times, this is negative 4 times negative 4. Now, order of operations says I need to multiply, so this becomes 16 times a negative 4. Okay, or 16 times 4, doesn't really matter, because this is a subtraction sign. So now I can do 16 times 4. 6 times 4 is 24, so that's 64. 2 minus 64, and we do know how to add and subtract positive and negative numbers. That ends up being negative 62. So you need to be careful to make sure that you understand that as soon as a fraction has one negative sign, it's negative. If it has 2 negative signs, it is indeed positive.